Hello friends, welcome back to our YouTube channel Mechanical Engineering Exams Made Simple. Friends, in this video we will see comparison of various different types of hydraulic turbines. Your hydraulic turbines is a part of your syllabus for your power plant engineering. In that various power plants are included like thermal power plant, nuclear power plant and a hydro power plant. So these turbines belong to the hydro power plants. So there is a comparison between the different types of turbines, okay, hydraulic turbines. So let us see this, and probably you can expect one or two questions. If you see this table very carefully and by heart probably, you can get at least minimum 1 to 2 marks. Let us see this. So let us see what is the various parameters here compared are the flow, maximum capacity, number of jets and or kinds of blades, and head under which the turbines are working, RPM, revolutions per minute, hydraulic efficiency, specific speed, regulation mechanism. Let us see. For Pelton wheel, this flow is basically tangential and single stage. It is a impulse turbine, single stage impulse turbine. The flow is tangential, and generally the maximum capacity for these turbines is 250 megawatts. So remember these wattage, friends, maximum capacity for different types of turbines. This will be very useful to you. So some fact based questions are given in your examination. Probably this data will be useful for such type of questions, fact based questions or database questions. Number of jets in Pelton wheel or kind of blades, let us say 1 to 6. So 1 to 6 normally maximum number of jets, and maximum 2 for horizontal and 6 for the vertical shaft. If the turbine of the shaft is horizontal, the number of jets are 2, and if it is vertical, then number of jets are 6, or maybe kind of blades. Okay. So now what is the head under which normally this single stage tangential impulse, that means Pelton wheels, are going to work? This is normally going to vary from 100 to 1750 meters, 1.75 kilometers. It's very huge okay, height, friends, okay, very big height, right? So normally this Pelton wheel is basically an impulse turbine, okay. So in which the what you call the energy conversion is basically kinetic only, okay. Only kinetic energy is responsible for the power generation, okay. That means the mechanical power or shaft power generation. So RPM under which this turbine is going to work is 75 to 1000, okay friends. So now then hydraulic efficiency, how much for this particular turbine? It will be for single jet, it will be 85 to 90%. And what is the specific speed? Because the specific speed is very specific speed will be normally it is proportional to inversely proportional to the H. Okay, you know that hydraulic turbine NS specific speed is equal to N root P by H to the power of 5 by 4, right? Yes, 5 by 4. NS is specific speed, N is the speed. So it is indirectly proportional to the height. If the head under which the turbine is working. Okay, so now this is H to the power of 5 by 4. If the head is very high, the specific speed is very low. Because for Pelton wheels, the head is very high. Say we have seen here, right? For example, 1.75 kilometers maximum, 1750 meters. So for this, because the height is very high, head is very high, the specific speed is very low. 6 to 60. And regulation mechanism normally this it will be through spear nozzle and deflector plate. Let us come to the Francis turbine. This basically it belongs to the type of inward radiator flow and single stage, and of course it's a reaction turbine. So in the reaction turbine we know that both kinetic energy, that means velocity head, and what you call this pressure head P by gamma, okay, is also going to contribute towards the mechanical power generation or shaft power generation. So and in this, what is the maximum capacity? It is going to be 720 megawatts. Okay, so number of jets are kind of blades. So this turbine is going to use the fixed blades, right? Right. Next, head under which this turbine normally works is 30 to 550 meters. Gradually, it is reducing. You can see, friends. Okay, so highest it is reducing from Pelton wheel, Francis turbine. Then comes your propeller turbines, etc. Okay, this is belonging to the axial flow turbine, Kaplan or propeller turbine. Let us see that afterwards. But here the head under which this Francis turbine will be working will be varying between 30 to 550 meters. RPM will be from normally 100 to 1000 RPM. Okay, so this hydraulic efficiency, how much it will be? 90 to 94%. This is more compared to the impulse turbine. Specific speed normally it will be more because the head is decreasing probably. So head is decreasing, specific speed increases gradually from impulse turbines to reaction turbines to axial flow turbine. Regulation mechanism, how this will be done, it will be through the guide vanes. So here in this impulse turbine, so this it will be like this, okay friends, okay, these are nozzle. So a spear will be coming, okay, so by moving this you can increase or decreasing the opening. This is called spear nozzle. In the reaction turbine, it is the guide vanes which are going to regulate the mechanism of the working of the turbine. Coming to the Kaplan turbine, that is also propeller turbine, okay. So adjustable blade turbine axial flow turbine is called the Kaplan turbine. Non-adjustable blade axial flow turbine is called the propeller turbine. So in the Kaplan turbine, the blades are adjustable. Okay. So now coming to the Kaplan or propeller turbine, it belongs to the category of axial flow single stage turbine, and it is a reaction turbine once again, right? Right. But the flow is axial, right? Right. In the Francis turbine, the flow is radial. So maximum capacity, how much it will be? 225 megawatts. It is very least. So when the power generation maximum capacity is less, we are normally going for Kaplan turbine or propeller turbine. So now what is the number of jets or kind of blades here actually? So here in the propeller turbine or Kaplan turbine, we have propeller turbine have fixed blades, while Kaplan turbines have adjustable blades. This is a basic difference between the axial flow reaction turbine, to which category Kaplan and propeller turbine belong. But in the propeller turbine, the blades are fixed, while in the Kaplan turbine, the blades are adjustable. That's the main difference. Now coming to the head under which this turbine will be working is 1.3 to 77.5 meters maximum. Okay, so it is maximum head is lesser than the minimum head for the Pelton wheel, which is 100 meters. Okay, friends, just please observe this. And RPM, so RPM will be again reducing. Okay, speed will also be reducing gradually from Pelton wheel to the through the reaction turbine, Francis wheel or Francis turbine to the Kaplan turbine or propeller turbine, which are the axial flow turbines. So it is very less, head is very less. So because the head is very less, specific speed will be very high. Because we have just seen that specific speed will be inversely proportional to the 1.25 to the power of the head. Hydraulic efficiency, if you see, so it is going to be 85 to 93%. Okay, right. So it is almost similar to the minimum is something comparing with the minimum efficiency of the Pelton wheel, and maximum efficiency is matching to that of the maximum efficiency of the reaction turbine, that is your Francis turbine. Now coming to the specific speed, so because the head is very low, of the order of maximum head is 77.5 meters, the specific speed will be maximum of 1100, 280 to 1100. So please just try to have a rough idea about these figures. Fact based questions may be given on this particular table. And regulation mechanism, how it will be done? It will be through the blade stagger. So through the blade stagger, this entire mechanism of the working of the propeller turbine or Kaplan turbine will be achieved through. So friends, in this video we have seen some fact based question. This table will be very useful for some fact based question that will be given from hydraulic turbines, which are part of your power plant engineering. So from questions from Pelton wheel, Francis turbine and Kaplan and propeller turbine. In the next video we are going to come up with some more videos for your AE Genco TS Telangana State exam, which has been postponed probably by, it may be postponed by 1.5 months or 2 months, friends, roughly, generally. If there is any postponement, minimum 1 month, maximum 2 months. So that you can expect, because of some candidates have represented to the government that other examinations are being conducted on the same date, like ISRO and some other examinations are there. So the government has decided to postpone the examination. So probably we will be having 1 to 1.5 month or maximum 2 months. So I am conducting online batches. So because the new government has taken place, so probably this time you can expect the recruitment to be fair enough, friends. Okay. So if you are interested for any online batches, you may be belonging to various places within the state, outside the state, and probably outside the country also, right? And maybe you may be belonging to the various places, remote corners also within the state, Telangana or Andhra, or maybe outside also. So if you are interested for any online coaching for this particular examination, you may contact me on my mobile number, which I will be providing you in the description box. Anyhow, I am writing here my mobile number. you can contact me on this particular number 119912507633. Okay, let us meet in the next video very shortly. All the best.